So, should I start the timer?
Oh, no, it's fine. It's fine.
Okay. So I'm going to talk about the topic is security. So I got this idea because currently I'm enrolled in cybersecurity course in my grad school. So I think that's a good idea to share what I learned in the course. So yeah, I'm a software engineer right now. I'm a grad student working on web application technology right now. And yeah, let's move forward. So the main question or the problem statement will be that can I implement my own custom encryption? The answer is yes, but you probably shouldn't do it, and I'm going to show you why. And let's see. There is a case. It's quite a big case study. It was from Telegram. So Telegram is implementing their own encryption protocols, and it's a problem because some researchers found that actually their implementation is insecure, and there is some academic study, I think. Yeah, they have a paper on it proving that it's actually dangerous to implement your own encryption protocol or algorithm. Okay, so I'm going to show you a demo that it will be related to RSA. So if you are familiar with RSA is what you use for if you are browsing. You see, you have HTTPS, the S is secure, or SSL or TLS, and they are using RSA algorithm. And these guys are the one that's researching on RSA and releasing the algorithm back in 1977. Okay, so yeah. So you can see all the certificate and public-private certificating, those are all built on RSA algorithm. And this is an example of RSA also. When you're using SSH to connect remotely to your server, you have the private key and you have the public key. And this is all too detailed. You don't need to see this, but what you need to know is there's two numbers when you're generating RSA. It's you can call it, usually people call it P and Q, and it's a very large prime number, and you need to generate those prime number randomly, as in truly random, not pseudo random. And I'm going to show you the danger of, like, for example, if you're developing your own algorithm and you need to generate a random number, and you're using something that's not really random, but usually people call it pseudo-random. So the example of pseudo-random generator is, if you're using JavaScript, is the function math.random. Those things are not random actually, it's pseudo-random. And I can show you that there's a library that we can use to predict the result of the math random. So yeah, okay. Let's skip that. That will be too long. So I'm going to show you. You can open up your browser actually, and just, for example, here you can call math random, right? This is what I'm talking about. When you call it, you can see there's a random number generated here, but this is not actually random. This is actually pseudo random. So there is a way to predict the output of math random, and that's dangerous in the terms of encryption and security. So what I'm going to do now is I'm going to prepare the seed of the random number, and then I'm going to put it here. So what I need to do is to generate 5 random number, and then I just need to put it here. So there's this is a repo. There is a library that someone else made actually. I will link the repo and also the YouTube videos that they made about this repository. But basically, this random number solver is using Z3 library. It's default by Microsoft Research. So basically, it can solve any mathematical problem given the constraints. So that's what I do. I don't really understand what the Z3. You can look at it if you are really interested. But I'm going to show you how I can predict the random number from just a seed of 5 random number. So I put, did I put it? Yeah, I did. Okay, so I put the seed of 5 random number, and then I'm going to call this this library, this application. See, so this will be the random number. Let me put it here, and then I'm going to generate the next random number here, and we will see if it's the same or not. Okay, so this is a number. I'm going to copy this, or maybe can I do it side to side? So yeah, it's the same number. So as you can see, the match random is not actually random, and the point is, if you are developing application for production, you need to be really careful on what library, what methodology, what algorithm you use. And getting back to the slide, yeah. So what's the best practice? The best practice would be for developers is to, the easiest way is just to go to OWASP. I will link the URL later in the Discord channel. And there's a lot of resource on security related things in the if you want to develop an application. And for example, there is a topic related to cryptographic storage, and you can see here regarding the custom algorithm, they just simply said don't do this because just don't do this, super dangerous. And yeah, so the key takeaway will be don't implement your own encryption algorithm. If you can, use popular or built-in library. Preferably that's something that's really popular, that's a lot of people is using, and a lot of people is reviewing the code and maybe reviewing the algorithm. And much better if you don't have the resource, or you don't have the team maybe for managing the password. Maybe it's better for you to use a third-party service to manage password storage or authentication, like what do I call it? Like Auth0 maybe, or like in the AWS, I think they also have their authentication management. Cognito, yeah, stuff like that. Much better to use things like that. And as much as you can, try to consult to OWASP recommendation. So yeah, that's about it. So any question?
Yeah, question. I mean, I think this is pretty wild. It says that how many previously pseudo-random results from math random did you need for the Microsoft library to be able to predict the next one? How big of a sample size do you need? Even if in the example that you gave us, how many did you have?
You only need 5 samples, 5 random numbers, and that's it.
How on earth is it working? Because my understanding of I absolutely understand that it's not completely random, but my understanding is that it is usually looking at the clock, right? So it's just taking like very insignificant bits of current time, and this is using those bits as the seeding for the pseudo-random number generator. So how on earth are they able to predict what number will you get next if they don't know when you call the function?
Okay, so the thing is, you're correct. So, but also there are a lot of ways to generate pseudo-random generators. One of them is like you described. Sometimes you need to take entropy, or you can say take randomness from something. Like maybe if you have a computer, like the temperature of the computer, the fan speed, how fast, in terms of RPM, how fast it's spinning, and stuff like that. You can generate the seed of randomness from everywhere. Actually, and the thing is, I don't really understand the details of the implementation on how to solve the randomness. But from what I understand is that in JavaScript, specifically in V8 JavaScript engine, they generate randomness from seed. I believe the seed is the true random number from the hardware, but subsequently after the seed, they use like a bit shifting to generate the random number. So by understanding the algorithm of the bit shifting, we can get an initial sample size like the first 5 random number generated from the browser, put it there, and then they can predict the next one. So by understanding, to understand your question, it's case by case, but They can predict because they know the algorithm.
But this brings me to my second question then. So, if all of this is the case, this is also pretty much how OTP works, right? For example, for your bank. You usually get a very long secret, but then that secret doesn't change, or it's a secret plus time or something else, right? That that gives you like the next code for the next 30 seconds. Does that mean that I would be able to use Microsoft Library to like generate shitload of codes? Because, for example, I have one of the hardware tokens for my Japanese bank, and I hate it.
Yes.
Because it's infuriating. Yeah. And I would like to bring it to like my software, like OTP generator. But obviously, they're not giving me the seed because they're not stupid. Yeah. So, would I be able to get if I feed it the time and the token that I got from my hardware Japanese token into the Microsoft library, would they be able to, if I had like, I have it, so I can generate a lot of them, would they be able to predict what OTP code I will get next at a given time?
To answer your question, in short, I don't know, but to discuss, there is computer is very deterministic, right? So in a sense, they're very deterministic, but you can make a random generator that is good enough.
That's my question. So my question is pretty much about this trend, right? So my question is about whether the solution space is too big for this to be a practical attack. That's my question. Right?
So I don't know if they are using it or not, but that's a very interesting question because it is related to our daily lives and it's related to our bank account, so it's very important.
OTP standard is an open standard now, right? I mean, if you have the secret, everybody knows how to generate OTP codes.
Actually, it's related to security. I mean, in general, if you want to implement a good security, you shouldn't do like security. You shouldn't do things like security by obscurity, if you know the term, right? It's better if you just publish all your, your security standard and process, stuff like that. What algorithm you use, even you can publish it if you want. And you need to put it on your mind that the malicious users or the attackers or whoever that is want to do bad things already knows the architectures or the system, and you need to make sure that even if they know, they cannot break the security system you put in place. So yeah, so I believe related to the OTP things that you mentioned, the physical token, right? I believe it's made by only several companies in this world, so maybe only 3 or 5 companies. So they just put a label or stickers or something. So I believe the standard, the protocols, the random generators inside is very open and generic. Maybe they have several things secret because it's a patent, but in general the methodology is basically the same. So
my question here basically boils down to how many bits are in the seed for the random number in the V8 engine versus how many bits do we have in the secret for the OTP for our banks, right?
Well,
and we don't know, but
we don't know.
I just wanted to pose another question. Oh man, if I could do it, I would throw away that piece of shit.
Yeah.
Sorry, that was my question.
No. It's okay. So anything else?
Okay. Any more questions? Security related? Okay, I was just wondering, this would work also if you're using a Node.js process rather than
it is.
from...
Do we have still a bit of time?
Maybe I can show it. About
if we have
1
2
or 2
minutes.
minutes. Yeah, actually 1 minute and 15 seconds.
I haven't tried it, but it should work because it is using the same
V8 engine.
Same V8 engine. You're correct. So let's see. Node. Wait. I don't want to write the array generating things. Let's see. Okay, so we get 5 random numbers. Okay, put this here. Yep. Okay, this is the new random number. Let's put it here. Let's delete this. And let's see what happened if we call not random. Boom, it's the same number, I think.
It looks like it is.
Yes, it is.
Wow.
So yeah, it's as long as it is using the same algorithm, or maybe the as long as it's using the MP8 engine, I think they can. They can predict the randomness. So yeah, don't implement your own security algorithm, encryption, stuff like that. Just use what's already there.
Thank you very much, Anzhari.